Most of you who have already experimented with the Linux kernel would have at least heard of the term device trees. Or, if you are a student, it is very likely that this topic has never come across you. Nonetheless, the kernel documentation is a great place to start with. To make it clear, we will not be going into the specifics of how to read the DTS contents using the kernel API. The purpose of this is to help folks visualize how device trees solve various pain points for kernel developers. Let's take a hypothetical example of a phone manufacturer who releases an overpriced phone each year and Linux is the core operating system running on it. As you can see, there are 3 variants of the phone which more or less have the same hardware. The Pro and Pro Max variants have certain additional hardware features. How do we maintain the kernel image for these 3 variants? From the perspective of a kernel driver developer, let's look at approach A, where we do not have a device tree. This instantly would mean that the 3 versions of the kernel image has to be maintained. Most of your hardware remains the same, but just for adding a couple of additional features you will have to maintain these additional images. Now imagine the pain of a developer who has to maintain hundreds of variants of a product with such minor changes. This is an unnecessary overhead for the developer and the vendor. What if I told you could compile a single kernel image with all necessary features you might ever need? Then you pass a file to your operating system at boot to tell it what would be the right hardware setup. At a higher level, this is simply what device trees do for you. Instead of maintaining 3 unique kernel images, you now can have just one with a device tree file for each variant. As you could imagine, the size of a device tree object would be much smaller than the entire compiled codebase of the kernel and would be significantly easier to maintain. If you open a device tree file, you would see something like this. Each property you see has a specific meaning it conveys to the kernel and your driver. Should this device or IP block be enabled? How do I find the driver in kernel source? What are the pins that are assigned to this device? And a lot more, but we will not go into depth here. Before we end, it would be worth it to peek into device tree overlays. As the name suggests, this is nothing but an overlay that is applied to your existing device tree. Let's go back to our initial example. Each variant has similar base hardware features. What can make this even better? Well, if we could maintain a single branch of device tree for all the base features and have the additional features added based on another device tree file. Hence, from the developer's perspective, we now end up with a single kernel image, a device tree for base hardware setup, and 3 overlays for enabling the features. Anytime a base feature is to be updated across all 3 variants, it only needs to be updated in a single device tree file. This might sound too much, but in a project huge number of peripherals and variants, the overlays will start to make sense. There is a lot more to explore when it comes to device trees, but each would require a dedicated video on its own. Do let us know what you want to see next. And don't forget to subscribe and follow us on our socials.